The last section of our factoring polynomials chapter has to do with some patterns that you might pick up and some shortcuts with factoring. So let's go back to something that you should recall from prior chapters, and that is this. What is the difference when you FOIL x plus 3 squared and x plus 3 times x minus 3? So let's do that and let's see what happens. So for this one, I am squaring a binomial. You know that you are to write it twice and then FOIL, which would give you x squared plus 3x plus 3x plus 9, or x squared plus 6x plus 9. Now I'm assuming by now that you know how to FOIL. So that's what I get when I do that. When I multiply x plus 3, though, times itself with a different sign, watch what happens. I get x squared outside minus 3x, inside plus 3x minus 9. Unlike this one where my O and my I were the same term, so they doubled up to make a 6, here my O and my I are opposites and they zero out. And I end up with just two terms, x squared minus 9, because, again, the O and the I zeroed out. So it says, which one of the two problems above gave an answer that looks like this? Something squared, the first thing squared minus the second one squared. Well, obviously it was this one. It was when you multiply and one's a plus and one's a minus. So you can write some conclusions here if you want, but I'm going to show you that we're going to use that knowledge that when you multiply something, let me bring this back down, times itself and one's a plus and one's a minus, that we can use that when we are factoring and we start with x squared minus 9, for example. It makes it easier to unravel back to the beginning. So for example, if I have z squared minus 4 and I'm supposed to factor that, I don't need to go through a process. I know it's going to be a FOIL, and here's what I'm going to say. What got squared to give me z squared? Z times z. I know that one had to be a plus and one a minus, and that to get 4, it was 2 times 2. I just know that because that's the only way that my outside and my inside terms would zero out. Here, y squared minus 25, I know it's going to be y plus 5 times y minus 5. That's the only way that I can end up with just two terms. This is such a common factoring and simple factoring. It has a name. It's called difference of two squares. And we talked about that when you were learning to FOIL. It makes for very easy factoring, even if one of them is a fraction. I know that I'm going to get y squared is y times y. One's a plus, one's a minus. 4/9. To get a 4, it took a 2 times 2, and to get a 9, it took a 3 times 3. So it's y plus 2/3, y minus 2/3. And by the way, it wouldn't matter if you wrote the negative one first and then the positive, so long as one is plus and one is minus. Now, what I don't want you to get mixed up with is that if you see this, it does not mean write it like that. It means write it times itself, both signs the same. And so your inside and your outside terms are not going to zero out. Now what I want you to do is I want you to pause the video and I want you to try to factor x squared plus 4. I want you to write down what you think x squared plus 4 would factor to. If you're smart, you will FOIL back your answer to see if it works. So pause the video. I'm assuming now that you did pause it and that I'm going to guess, because I've had other students before, that some of you said, oh, that's x plus 2 times x plus 2. Some of you might have said, oh, that's x minus 2 times x minus 2. And maybe even some of you said, oh, no, that's x plus 2 times x minus 2. So let's test each one of those and see if we can get x squared plus 4. Here we would get x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4. We did not get x squared plus 4. We had this extra term. Didn't work. Sorry. Here we would get x squared minus 2x plus 4. So here we got the x squared and the plus 4, but we also have this extra term in the middle, minus 4x. That didn't work either. And I'm pretty sure we just talked about this one. This is going to give us x squared minus 2x plus 2x, so that's good. Those are going to go away. But my last term is going to be a negative 4. That didn't work either. The truth is, this is not factorable. It is prime. It is prime. So the only time two terms is factorable is if there's a GCF, or if they're both perfect squares and the middle sign is negative. If it's positive, unless there's a GCF, it is prime. So when I look down here, I don't even need to go any further. It's prime. There's no GCF. Even though they're both perfect squares, that plus in the middle, it can't be factored. This one, however, it can because it's a minus. So I know that what got squared to make 4y squared? 2y times 2y. One's a plus, one's a minus. What got squared to make 9? A 3. That one is factorable. This one, it's a minus, perfect squares. It is factorable. It's 2x plus 1, 2x minus 1. This one, it's a minus. They're both perfect squares. It is absolutely factorable. This would be 5a plus 3b. That's what got squared. And 5a minus 3b. This one, tricky. This one is factorable because it's not a plus, it's a minus. It's y squared plus 4y squared minus 4. But we're not finished, because if you look carefully, this one is another difference of two squares. This one is prime. I'm going to use space down here. So this one is still y squared plus 4. It won't break down. But this one breaks down again into what got squared to make y squared? Y, one's a plus, one's a minus, 2. So this one actually has 3 factors at the end. 3 factors. And the reason it was factorable again is because we started with a 4. So when I got down to here, I still had something that was squared. So what I would like you to do is to come up with 5 different difference of two squares factoring problems on your own. I'll give you a minute to do that if you pause. Coming back, I have absolutely no idea what you came up with, but I'm going to list a few. I could have y squared minus 9. There's an easy one. I could have 100 x squared minus 25. As long as those are both perfect squares, it will work. I could have 9m squared minus 36n squared. Those are both perfect squares, etc., etc. What I cannot have is a plus in between. All right, looking at the next page, I have some regular factoring here for you that just happens to have a pattern to it. And you know, if you notice the pattern, that's great. At this stage in your mathematics, if you don't see the pattern, it's okay because you actually have a process for doing all of these. So let's look at example 4. It says to factor x squared plus 8x plus 16. First, it's a trinomial with a 1 on the squared term, so it's a short process. I need factors of positive 16 that combine to make positive 8. They just happen to be 4 and 4, both positive. So it would be x plus 4, x plus 4. And what makes this a pattern is that I can write that as x plus 4 squared. And if you notice the relationship of the 16 to the 8, you could have jumped right to here. But you know what? It's almost just as fast to just go ahead and do that short process. Here's another one with the same relationship between the 36 and the 12. If I'm looking for, short process, factors of 36 that combine to make positive 12, it's positive 6 and positive 6. It's one of those doubles kind. So it's x plus 6 times x plus 6, or x plus 6 squared. And again, I'm just not that interested in whether you really have to see that pattern. You have to see the difference of two square pattern. This one is just handy. It might save you 5 seconds. Here, a little bit nicer if you could see the pattern, but this is a harder pattern to see. This is a long process trinomial. So I say 4 times positive 9 is positive 36. I want factors that combine to make positive 12. We just did those. Positive 6 and positive 6, but now they're used differently in the long process. So I break down the middle term into 6x and 6x. Bring down the last. I group. GCF of the first binomial is 2x, and I'm left with 2x plus 3. Bring down your plus. The GCF here is 3, and I'm left with 2x plus 3. And here's what makes this unique. So what I have is 2x plus 3 times, look there, another 2x plus 3. So you could have written it as 2x plus 3 squared. Now, how would you know that? Just by looking at this. I'm going to show you once, but we're not going to make a big deal about it. 4x squared was a perfect square. It was 2x that got squared. 9 is a perfect square. It was 3 that got squared. If I multiply those together, I get 6x, and the middle term is 2 of those. So I knew that it would be that. But you know what? I would just as soon you go through and do the long process. So it says, did you notice a pattern? You can describe it here. We're going to go ahead and try. I'll do the easy one for you, the shortcut method. As soon as I see that this is a perfect square, it's 7 times 7, and this is 7 plus 7, I know it's going to be x plus 7 squared. Here, I can't say that. This is a perfect square. It was a 2. This is a perfect square. It was 5x. Multiply them together, 10x. Double it, it's 20x, so it should be 5x plus 2 squared. However, what I would want you to do is go ahead and do the long process where you're looking for factors of positive 100, 25 times 4, that add up to positive 20, 10 and 10. And then if you do your bring down, break down, bring down, this is what you're going to end up with. So it can be handy, that pattern, but rely on the processes I've already taught you. Basically, it says if the trinomial is of the form a squared plus 2 of the things multiplied together plus b squared, the factored form will be a plus b squared. The same thing works with subtraction. Here, I would want you just to factor it using the short process. Factors of positive 1 that add up to negative 2 are negative 1 and negative 1. Since this is a short process, it would be m squared, that's how you get m to the 4th, minus 1 times m squared minus 1. Now we know that we're actually not finished because these are difference of two squares. So this then would be m plus 1, m minus 1. Same with this, m plus 1, m minus 1. It's not really necessary to see that pattern. On this one, 9x squared minus 12xy plus 4y squared, that process is a long process. So I say 9 times positive 4 is positive 36. I need factors that add up to negative 12, negative 6, and negative 6. And so now we are going to break down this into these two pieces, negative 6xy minus 6xy plus 4y squared. 1, 2, 3, 4, so we know to group. Negative means make that correction. The GCF here is 3x, and you're left with 3x minus 2y. Bring down your minus. The GCF here is 2y, and you're left with 3x minus 2y. You can see that those match. 3x minus 2y, and what makes it a pattern is that the second one is the same thing. But I wouldn't expect you to recognize it here, not at this stage. So trying a couple more, it says, did you notice the pattern? If you did, good for you. If you didn't, just rely on your factor processes. I would like you to try these. I'd like you to pause the video and try these on your own. I'm assuming you did that, and you should have gotten for this one m minus 8 times m minus 8, or m minus 8 squared. For this one, you would have had to do a long process, and what you should have gotten was 3m minus 5 times 3m minus 5, or 3m minus 5 squared, with that long process. So the conclusion here, if you see the pattern, if you have a trinomial that has this situation, the first term is a perfect square, second term is a perfect square, the middle term is 2 of the 2 multiplied together, then it's going to factor to a minus b squared.